So the next question now we want to talk about is what happens if you use white light, because so far what we have been doing is using monochromatic light using laser. So if you're using red laser, then your image will only be red lah. But using white light, you will actually get a full spectrum, right? Because white light consists of the full seven colors lah. So what will happen is this imagine you do it one by one. You use the formula d sine theta equals to n lambda for each of the different color. Now in the middle will always be a bright fringe, right? So in the middle, all the colors will overlap to give you white. So in the middle, you will definitely get white. But after that, you will notice that as you go down the spectrum of the visible light, the wavelength will increase this way, right? So when the wavelength goes up, the theta will go up. So in other words, the one with the smallest wavelength will have the smallest angle. So you notice that if you use the rainbow sequence, violet will be the smallest wavelength, so be nearest to the middle. And red will have the longest wavelength, so they have the biggest angle, so it's furthest. So for the first order, you will get a rainbow spectrum on both sides. But for the second order, you also will get a spectrum, but it's a bit fainter. That means it's not so bright. Why? Is because when the light passes through a diffraction grating, okay, let's say this is a diffraction grating. Now the light will spread at every slit, right now. But the further away you go from the middle, the light from this other side won't be able to reach. So you get fewer light interfering at this angle. And also on the other side, the light from this side won't be able to reach here when it spreads. So you have fewer light interfering here lah. But what will happen to third order and above? Now usually there is a chance that the third order will be separated. That means the third order could be separated from your second order. That means not overlapping. This will be a third order. But there's also a chance, depending on the number of lines per millimeter, the capital N that you're using, how much it spreads. If it doesn't spread much, that means you will notice that if you're doing the experiment in the lab, right, the bigger the N, which is the number of lines per millimeter, the more it will spread. Why? Because you're going to squeeze in more lines in 1 mm, so you make each slit narrower. So therefore it's more spreading. Then the pattern will be very far apart. That means between the first order and the second order, it will be very far apart. But if your N is small, then the lines won't be so small. It will be quite big. So it will be less spreading. So then what happens is the first and second order will be very close. And if the second order and third order will also be closer. And if it's closer, there's a chance that part of the third order will overlap with part of the second order at the edges. So you can imagine that maybe this is your third order, so this region of your third order actually overlapping a bit of your second order. So there's always a chance of that as well. So when they overlap, that means when you use d sine theta equals n lambda, for the second order, then as usual, we will use the n as 2. Then if it overlaps with part of the third order, at that point where it overlaps, then you can use if you're solving for third order, you use 3. But the theta is the same. So you use back the same theta. So sometimes you will get full spectrums, sometimes you have overlapping. So if it's overlapping, you use the same angle.